Alright guys, in this video we're going to talk about units. That's what we're going to start with. And I know everybody's probably heard of units before. You've seen it hundreds of times, I'm sure. But we want to go over it just to make sure everybody's on the same page here. So a unit is essentially going to be a quantity that's been adopted as a standard. Alright, so that way the people in one location know that a foot, for example, is the same thing as a foot in another location, right? So everybody has the same standard of measurement, okay? And it's the same thing for, pressure, temperature, all of these things. Okay, so a unit is just going to be a standard of measurement. And here are some examples of units of length. So we got meter, foot, miles, kilometer, all of those are units of length. Now we're going to have two systems we're going to work in this course. We've got the SI system, which is also called the metric system, and then we've got the English system. Typically the SI system is easier to work in because the English system has some conversions that students typically don't necessarily enjoy. So we will do both units though, both systems, just so you get practice with both. Let's go ahead and make up this little table. We're going to put our four commonly used quantities. Okay, so let's start with mass. Now these next two columns, these are for the SI system, and then after that we've got the English system. Let me focus that again. Okay, so for mass, our units, we're going to have kilogram, and our symbol for that will be kg. Now for English, we're going to have pound mass. Symbol there will be lb. So sometimes you might see an lb with an m subscript. For this course, I'm just going to use lb. Keep it simpler. Next, we've got length. So a unit of length in the metric system is going to be a meter. Symbol there is m. And in the English system, we're going to have a foot. Then we have ft. Okay. Next, let's do time. Time is easy because it's the same for both systems. So base unit of time will be seconds. Symbol is s, and then same thing in the English system. And then finally, let's look at force. So for a force, we have a newton in the metric system. Symbol there is N, capital N. Now a newton is a derived unit. So remember, 1 newton is 1 kilogram meter per second squared. And if you ever have a hard time remembering that, remember force equals mass times acceleration. Okay, so mass is kilogram, acceleration meter per second squared. Okay, and then force is newton. In the English system, we're going to have pound force. And that system or symbol will be lbf. Okay. Now we have the conversion that 1 pound force is equivalent to 32.174 pound-foot second squared. All right, and we'll use this conversion as we go through. But this converts force over to pound mass and then acceleration units. So foot per second squared. All right. Now we have other quantities we're going to look at. We're going to look at temperature, we'll look at pressure, density, things like that. But we'll talk about those units as we go through when we explain all of those things. All right, so next let's do a couple of examples on doing unit conversions, because we are going to do a lot of unit conversions. So here's our first one. We're going to do 1 liter to cubic inches. So always start out with the original one that you're given. So 1 liter. We need the conversion. Now in the book that I use, the conversion given is to cubic feet. So there are 0.0353 cubic feet per liter. Now the liters here cancel, but now we've got cubic feet. Now we don't want cubic feet, we want cubic inches, right? So we need to convert over to inches now. The conversion we need is 12 inches per foot. Now are we done with that? No, not done. Because notice this is cubic feet, this is just feet, we need to cube this. That will give us cubic feet, which will go away. Now the mistake a lot of students make here is they will just do 0.0353 times 12 and they think they're done. Now that is not right. Because you've got this cube on here, right? So really you're going to do 0.0353 times 12 cubed. Now when you do that, you get 60.998 inches cubed. And then that's your answer. All right. So I put this example in here because people miss that little step pretty frequently. So make sure you pay attention to that. All right, so next let's look at this one. This one's going to be for pressure. Okay. So we've got kilopascals, which is a unit of pressure, and we want to convert it over to PSI, which also is a unit of pressure. So let's write down the initial one we were given. Now, a lot of the times the conversion tables are not going to go from kilopascal to PSI. So it's going to go from Pascal to PSI. So we need to convert over to Pascal first. And there are 1,000 pascals per kilopascal. So now these two cancel. Now let's do our conversion over to PSI. So there are 1.4504 times 10 to the negative 4 pound force per square inches per Pascal. All right. Now cancel those out. Now you're left with PSI, which is exactly what we want, the pound force per square inch. So we just multiply the 304 times the 1,000 times this 1.45 number. And the number you get is 44.09 pound force per inches squared. Like that. Okay? So unit conversions are going to be important in here. In all of our problems, I'm going to leave all of the units in the problems, and I'll always go through and I'll cancel them out so you can see where they're coming from, what happens to them, because otherwise if you leave those out, a lot of the times students get kind of confused as to what happened to them. So if I were you, when you're working out your problems, I would keep all of the units in your problem. Okay? And it can also help you figure out if you're doing a problem correctly, because if your units aren't working out, then you probably did something wrong. Okay? Alright, so let's stop this video here and we will pick up next time with specific volume. Thanks, guys.